Hello everyone, so welcome back to another episode of Enlear Academy. Now in this episode, we are going to talk about EventBridge Scheduler. So in this episode, you are not only learn about Amazon EventBridge Scheduler, but also how to use Amazon EventBridge Scheduler in your existing architecture. So let's get started. So we have been discussing about Amazon EventBridge, the umbrella service. So we discussed that Amazon EventBridge is a serverless service that we can use it in our event-driven architectures to connect application components using events. So this Amazon EventBridge, there are three main offerings, which is Amazon EventBridge Pipes and Event Bus and the Scheduler. So in last two episodes, we discussed in detail about Amazon EventBridge Pipe, which is a point-to-point integration feature or tool. And then we also talk about Event Bus, which is used for many-to-many routing. So we discuss in detail about these two serverless services, and today we are going to talk about EventBridge Scheduler, which is nothing but a serverless scheduler service. So if you haven't watched these two previous episodes, I will put those two links. So we discuss in detail, and also we discuss how all these two features or three features rather are used in an application architecture. So this is the application architecture that we had been discussing. So before starting today's episode, let me tell you what we have been discussing so far. So we were building an application architecture for an airline web application. So in this airline web application, the passengers can order value-added services after they book the itinerary. For example, if they wanted to order Wi-Fi, an extra meal, or whatever the other value-added services that the airline provides, they can use this service. So essentially, they will create their orders or request their orders, and those orders will be intercepted by an API gateway, and there's a Lambda behind it that will add those records or the orders into a DynamoDB table. And this is the place where we use EventBridge Pipe to connect two services together. So EventBridge Pipe, like I mentioned, is a point-to-point integration. So we enable DynamoDB stream in this DynamoDB table. So EventBridge Pipe use this DynamoDB stream as the source and then target as the EventBridge event bus. So once the order events persisted in the DynamoDB, they are ingested into a EventBridge event bus. And then we talked about EventBridge event bus, which is a fan-out service where we can connect multiple subscribers. So here, when the events are added to event bus, so we have connected and step function. So step function will process the orders. So whenever the order has this order type order created, so what happens is we have defined an EventBridge event bus rule, and that will trigger the step function so it can process the order. So once the processing is completed, we send another event, the order complete event, and then we have other subscribers that are interested on order complete event. So we have already discussed about how can we connect these other subscribers, such as a queue that will be used to calculate loyalty points. And today we will talk about another subscriber, which is another Lambda function that will be used to schedule these events in an EventBridge scheduler. So this is where we are going to pick up from where we left off. So imagine now once the passengers requested their order and paid for their value-added services, we probably wanted to send them some reminders when their departure date is closer. Hey, okay, this is your itinerary and these are the value-added services that you have already ordered. So we wanted to send that email notifications when their departure day is closer. So we don't want to send that immediately, but let's say now a day prior to their departure, we want to send that email. So that's where we will use EventBridge Scheduler to schedule that event. So in this episode, let's discuss in detail what this EventBridge Scheduler is and how we can use it in our application architectures. Alright, so this is the agenda for today. We will give you an introduction about EventBridge Scheduler, and we'll talk about limits and quotas. So this is very important. Whenever we are using and managed service, we need to know about their limits so that we can make sure that we take the correct decision. And the pricing aspects, and also different schedule types that EventBridge Scheduler supports. We'll discuss about the targets and also how do we group our schedule and how can we use that. And also I will show you how we can provision all these services with AWS CDK. Alright, so let's get started. So what really is EventBridge Scheduler? So EventBridge Scheduler, like I mentioned, is a serverless scheduler and it's highly scalable. So if you wanted to schedule millions of tasks, you can do that. Now, one of the powerful things about this EventBridge Scheduler is that it can invoke 270 plus AWS services, including 6,000 plus API operation, which is really a powerful feature in serverless scheduler. We'll talk about it in just a little bit. And the other thing is this EventBridge Scheduler supports flexible timing windows. So what does that essentially means is at the time that you wanted to send your schedule, you can define a flexible time. So you are not like sending right away all these schedule to the target. You can define, let's say, once the schedule time arrives, in next 15 minutes, try to send this schedule. So with that, what happens is we are dispersing the schedule during a defined window, and that really improves the delivery reliability of events. Now, one of the use cases that you would use flexible time window is that when you have like lot of schedule going off at the same time and you don't want to like send all those requests to your downstream target. Probably if you send like a burst of traffic to your downstream target, they can break. So in that case, you can use flexible time window and those requests will be sent during the flexible time window that you define. So it improves the delivery reliability. But of course, if you need to send the schedule at the same time that they are scheduled, you shouldn't use it. And this flexible time window is an optional attribute or optional configuration that you can do. So you can use it based on your use case. Next, EventBridge Scheduler allows you to create schedule in 3 ways. First, you can use a cron expression. So for example, you can say, I want to schedule an event on every Monday at 8 a.m. So you can do that. So in every Monday, it will be triggered. So it's like a repeated schedule. And also you can use rate expressions. You can say in every 2 hours, send an event to the target. So that is also a repeated event, right? And also you can do one-time invocation. So you will define at this timestamp, make sure this event goes to the target, or you can also define this flexible time window. So those are the 3 ways you can use cron or rate expression or one-time invocation. Now, in addition to that, EventBridge Scheduler also support time zones. So by default, I think it's UTC. So UTC is the default, but you can define your time zone as well. But keep in mind, like if you have like too many time zones configured, then it can get a little complex. So it's best that you can stick to a one time zone. UTC may be preferable. And also, if you wanted to make sure that your schedule are adhering to daylight saving, you can enable that as well. So this is the EventBridge Scheduler. So important thing to remember is this is a serverless service. That means you are not paying upfront unless you're actually using it. All right. So before we go forward, let me show you how it looks like in AWS Console. You can go to AWS Console and search for EventBridge. Amazon EventBridge. And there on your left side, you will see the features that it supports: buses, pipe, scheduler, and so on. So here you can select scheduler. And you will come to the scheduler landing page. So it shows how it works and so on. And you can see there are no schedule in my schedule right now. Now look, you can't create a scheduler, so to say. So there's only one scheduler for you. You can create or associate schedule in it. So you can create schedules, not a scheduler, right? So if you want to create a schedule, you can click create schedule here or here. So let me click this one. And then you can give it a name. It says schedule 1 and description, optional. And here we can associate a schedule with a group. So what happens is all the schedules that are associated with this group can be deleted at the same time. So if you delete the group, you can delete it. And also you can list the schedule under a group as well. So by default, everything added to this default group. and you can go ahead and create a group and then associate it with that group as well. So right now I'll leave it as default. And then it's the schedule pattern. So I talked about 3 ways that we can schedule, right? So one-time schedule as well as the recurrent one. So the recurrent one includes that cron base and the rate base expression. So if you want to schedule an event on every Monday at 8 a.m., you can define that corresponding cron expression. So if you don't know cron, click here and then you will get to a page that talks about cron expression. So here, this is the way that you can define cron. So this is syntax and these are the values that we can use. We have some examples as well, you can follow along. But if you want to use rate base, so it's pretty easy. So you can define the rate. So I can say every 2 hours. So every 2 hours, EventBridge Scheduler will fire up this schedule. And look, this is that flexible window time. So both in cron base or rate base, you can define that flexible time window. So I can set 15 minutes. So in this case, I define this rate based schedule in every 2 hours. So when the first schedule is fired and after 2 hours, then the next schedule will be sent within the next 15 minutes. So now it will fire it, and after 2 hours, so the 2 hours elapse. So then again we have 15 minutes window, right? And then it will during this window it will send the next schedule. So this is the first one and this is the second one, right? Flexible time window always come after that 2 hours. So it's similar for the cron based expression as well. So on the time that your cron expression needs to fire, so then after that another 15 minutes. So within that 15 minutes it will fire. If you want to create a one-time schedule, there also you can define that flexible time window. So you can define the date and time. So here I will say, okay, on this day at this hour. So we have to use 24-hour format. So now it's in the 1 in the morning. So 1:06. And this is the time that I am based on, UTC. Or you can just use UTC as well. So right now I'm on Asia Colombo. And here also I can define some flexible window. If you don't want to do that, you can turn it off. Okay. So it's 1:06 and now it's 1:05. So let's click next. And now I can define the target that I want to invoke. So here there are like bunch of targets. So we haven't yet discussed about the targets. So when we want to set up a target, there are 2 things, like we have templated targets or universal targets. So we'll talk about that in detail, but essentially templated targets, you can directly link up a Lambda function or SQS queue, or send that event to a Kinesis stream, or publish that event to EventBridge bus, step function invocation, SNS. So there are a set of already templated targets. So if you are using a templated target like this, let's say I want to invoke a Lambda function, so you can just select your Lambda function. So I will just select one of the existing Lambda function, and then you can define the payload. So when you're defining the payload, you can add your attributes and the values from the message in the scheduler event. So you can say the name, and then you can map the data from your event. So we'll look at that, how to do that a little later during our demo. But here I'm not gonna set any payload, and I click next, and now I can enable the schedule, and then I can define the action after schedule completion. Now this is a one-time action, right? So that means once this is fired, then this will look for what's the next action. So I can either define delete or none. So if you select none, the schedule will remain in the scheduler, but be mindful, there are some limits. We'll talk about limits just a bit. Or you can set it to delete. So once the event is scheduled, it will be deleted automatically. And then we can also define DL queues for the scheduler. So if the schedule is unable to send the event to the target, then it will do the retry. So you can define the retry, right? You can enable retry, and you can define the retry attempts. So like, let's say I want to retry at least 5 times. And when you define that, it will exponentially added delays as well when it is retrying these 5 times. And also, if all these 5 retry attempts failed, then you can direct that to a DL queue. So you can set a DL queue and that message will be landed on the DL queue. And also you can define the max age of the event. So let's say I want to only keep an event for 3 minutes, right? So in this case, whichever comes first, either it exhausts the retry attempts or the maximum age of the event expired, then it will be sent to the DL queue. So right now I'm not setting up any retry policies, and I can encrypt as well. So here by default, EventBridge Scheduler encrypts the event using AWS owned key. But if you want to use your custom KMS keys that you manage, you can do that too. So here you have to check this box and then select your custom KMS. And then the permission. So when it comes to EventBridge Scheduler, in order to invoke the target, you have to make sure that the scheduler role has the permission to invoke the target. So this is just like in any other AWS service. So in order to invoke another service from one service, that invoking service should have the permission. So here also you can define a role for your EventBridge Scheduler, and that role should have the permission to invoke the target. In this case, we are going to invoke a Lambda function, so it should have Lambda invoke permission. I can click next. Oops, I should select no for DL queue, and now I can click next. So this is the review and create schedule page. Now I can adjust any details. So here I will edit it. So I want to invoke one time at 1:13. Okay, and skip everything, and then I will create the schedule. Okay, it's created, but now it's 1:13. Not sure if it triggers the target. So let's see if it triggers it. So if you go to target here in the schedule that you created, right? So for each schedule, you can define different targets. So this schedule that I created, the target is the Lambda function. I click on it. I can click monitor, CloudWatch logs, and let's see if I see an invocation. And here you go. I have an invocation. So the schedule in my scheduler invoke this Lambda function. Now, do you remember we set action after complete to delete? So that means if I click here on the schedules, I shouldn't see any schedule here. Look, there are no any schedule. That means after it trigger my target, it deleted it. Okay, so let's get back to our slides because there are a few things I want to discuss. Okay, I want to talk about limits as well because it's important that you know the limits and quotas. So this serverless scheduler service, it guarantees at least once delivery. So meaning that it can introduce duplicates events to the target because it's not guaranteeing exactly once delivery, at least once delivery. So what does this mean is you have to make sure that your targets have idempotent logic in place in case that they receive duplicate events. It shouldn't like break your system. And then when you're creating schedule, you can create 250 to 1000 schedule per second or the throughput. And this varies based on the region that your scheduler is in. And these are soft limits. That means you can send us AWS support request to increase these limits provided your use case is a valid one. And also the number of schedules. So this is an important one. So the number of schedules that supports in Amazon EventBridge Scheduler is 10 million. So you can have up to 10 million schedules. This is again a soft limit, but the recommendation is so once your schedule are sent to the target, you probably want to delete those events as well. But what if that you don't want to like miss those events? In that case, what you can do is probably you can back them up into a DynamoDB table. But although this looks like a big number, you can reach this limit quite easily, particularly if you are working with the high throughput scenarios. And this is again an important limit, the precision. So you can define these one-time schedules with the EventBridge Scheduler, but that doesn't mean it is exactly triggering the event at the time that you define. So the precision is 60 seconds. So within this 60 seconds, it can deliver your event to the target. But what if you want like high precision? So in this case, probably you should use step function. In step function, you can define wait states. In the wait states, you can exactly define, okay, at what point should the step function continue after the wait time. So if you need like high precision, probably you should go ahead with a different service like step function. But at EventBridge Scheduler, precision is 60 seconds. And invocation throttle limits is also in place. So there's like 500 to 1000 invocations to the targets per second. So this is the throughput. And this is also soft limit. So if you want to increase these limits, you can definitely create a AWS support request and increase them. So what about the pricing? So when it comes to EventBridge Scheduler, it provides a generous free tier. Here, 14 million scheduled free invocation per month. And this is always free. Just like AWS Lambda has, I think million requests free per month. In Amazon EventBridge Scheduler, 14 million invocations are free. And this is always free. And every month, you will get this 1 million invocation free. And after that, you will be only charged $1 per million scheduled invocation after that 14 million invocations. And this, I would say, quite generous pricing for EventBridge Scheduler. Okay, so let's talk about schedule types. Now we already discussed about this. So there are three types of schedule types. So we have the rate-based schedule, cron-based schedules, and one-time schedule. So rate-based schedule, like we already mentioned and saw it on the AWS Console, we can set a schedule to run on every 5 minutes, 2 hours, every day, and so on. We can also create a schedule based on a cron expression. So both of these rate-based and the cron-based, they are recurring schedules. And also we can do one-time schedules as well. So when you are using a one-time schedule, you have to define this date and time in this manner. So it's suppose UTC or any time zone that you specify. So we already seen it in the AWS Console, so I'm moving on. So let's talk about scheduler targets. So here also we saw there are two types of targets, the templated targets and universal targets. So in the AWS Console demo, we looked at how to set up a Lambda function as a target. So in addition to that, you can do SQSQ, step function, kinesis, EventBridge, SNS, and there are a few other templated targets. And also it supports universal targets as well. So in universal targets, it supports wide range of API operations and many AWS services. So at the beginning, if you can remember, we discussed that AWS EventBridge Scheduler supports 270 plus AWS services and 6,000 plus API operations. Alright, so what's the difference between template target and the universal target? Now when we are defining a template target, we have to define our target in this manner. So we have to define the ARN of the target. So in this case, we want to send a message to SQSQ when the schedule goes off. So here we will define the ARN of the SQSQ. Look, ARN, SQSQ, ARN. And then we define the message data that we are sending into the SQSQ in input. So as the input, we define the data. Okay, this is the data that we are passing on to this SQSQ. And then we have the role ARN. So role ARN, nothing but the scheduler role ARN. So in order for EventBridge Scheduler to invoke a target, it should have the permission. So the ARN or the role that we associated to the scheduler should have the permission, and we are passing that role ARN when we are configuring this target. In the AWS Console demo, we looked at how to do Lambda invoke as well. So there, instead of this SQS ARN, we use the Lambda ARN. Now, when comparing the templated target with the universal target, they are pretty much the same except for this ARN, right? So here also we define the target and we define the role ARN, that is the scheduler role ARN. So a scheduler should be able to invoke that target. So in this case, let's see how to define SQS queue as a universal target. So here the role ARN should have the permission to send messages to SQS queue. So that's one thing. But here the ARN is different. So ARN, earlier in the template target, we defined the SQS queue ARN. But here, when we are defining that as a universal target, the format is something like this: ARN colon AWS colon scheduler, and then colon colon another colon, and then we define AWS dash SDK SQS queue send message. So this is that API operation that we wanna invoke. So it's a send message of SQS queue in AWS SDK. So the ARN format is in this nature. So if we want to invoke a Lambda function, again ARN colon AWS colon schedulers colon 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 AWS dash SDK colon Lambda colon invoke. So like that, you can define the AWS service that you want to invoke and the operation. So this is the AWS service and the operation. So now let me show you in AWS Console how to configure a universal target. So here in Amazon EventBridge service, we can go to the scheduler and then go ahead and click create schedule. I will say this is my universal schedule, so schedule number 2, and I'll use the same schedule group. Let's do a one-time invocation and the date and time. No flexible window. Click next. And here, instead of template targets, I will select all APIs. Look, it supports a lot of AWS services. You can see the number of pages it has, and it goes even beyond that. So earlier we invoked Lambda function as a template target, but now let's try to invoke a Lambda function as a universal target. I'll search for Lambda, and now I have to find the API operation. So it should be invoke API. Invoke. There you go. So this is that API that we want to use, and let's use the Lambda function. So I will do my H Lambda, the same Lambda function, and the payload is nothing. I'm not passing any payload into Lambda function, and click next. And after schedule, I will delete it. No retry, none. And we'll go ahead and create the role. So here, when you select this one, it will automatically create the role for the scheduler, including the permission for this target. I'll click next again, and then I'll create the schedule. All right, so it is created. Now, if I click schedules here, I should see the schedule that I created, and that is a Lambda invoke type. If I do a refresh, there are no schedule. That means I have already invoked that Lambda function. So this is that Lambda function. Let me go in there, and then I'll go to the monitor section. I should essentially see another invocation. There you go. I'll go to view CloudWatch logs, and so this is the latest invocation. So this is the latest invocation. So this is our previous invocation. So here we configured that as a templated target, whereas here we configured as a universal target. All right. I think now you guys have a good understanding about EventBridge Scheduler, and let's see how we can use EventBridge Scheduler in our existing architectures. Now we have been developing this architecture from the lesson 1, and we are going to associate EventBridge Scheduler in this architecture. All right. So I think now you guys have a good understanding about EventBridge Scheduler. Now let's see how we can use EventBridge Scheduler in an existing architecture. So we have been developing this application architecture since the lesson 1. So here we have a airline web application, and the passengers can order value-added services such as meal, Wi-Fi, so on and so forth. So all their requests will be received by an API gateway, and there's a Lambda behind it, and add those orders in a DynamoDB. And then we have EventBridge pipe. So EventBridge pipe is listening to this DynamoDB stream, and then add all those order event in an EventBridge event bus. So then we have event bus rules configured. So whenever an order is created, so this rule get triggered and the step function is going to process that order and then send another event to the event bus, that is order complete. And then we have another two rules. So one of the rules is listening into this order complete event, and that is going to send that event into a SQS queue. So this is our loyalty point processing queue. And today we are going to create another rule, and that is also listening into this order complete event. So this rule is going to invoke a Lambda function. So this is that scheduling Lambda, and this scheduling Lambda is going to extract all the information from the event which is related to the order and then schedule that event in a EventBridge scheduler. So when let's say a day before the departure, we can send a notification to the passenger. And when we are scheduling this event, we define another Lambda as a target, and that Lambda is a notify Lambda. So at the scheduling time, this notify Lambda will be triggered. And here I'm using this intermediate Lambda, scheduling Lambda, to extract the data and then schedule it in the scheduler, because there's no direct way of inserting that record into a EventBridge scheduler. So that's why I'm using this Lambda. And in addition to that, I have also configured a DL queue for the EventBridge scheduler. So if the EventBridge scheduler is unable to invoke this target, which is that notify Lambda, it will try up to the number of retries that I have added. And if it is unable to do so, it will send that event to the DL queue. Let me show you how I added that configuration in the CDK. So this is my CDK project. So I'll go to lib, and this is my stack. So in my stack, I have this EventBridge event bus, which is this one. So this is that event bus. And now I'm creating rules. So I added the rule at the end. So this is that rule. So I call this rule schedule notification rule. So here it is listening to this order complete event. You see the detail type is order complete. And I'm defining the target. So this target is my Lambda, the scheduling Lambda, which is this one. So this is that Lambda, and I'm passing the information related to the event. So when I'm calling that Lambda, I'm passing the order ID, passenger name, email, flight ID, flight details, and the items that the passenger is ordering. So this Lambda, you can see I have defined up here. So that's the Node.js function, and it is living in schedule event folder index.js. So which is here in the Lambda schedule event index.js. So this is the Lambda. As you can see, it is invoking or adding that record in the EventBridge scheduler, scheduling it in the EventBridge scheduler. So for that, it's using scheduler client from AWS CDK client scheduler. And I'm also getting that create schedule command. So this is like DynamoDB. So first you have to create DynamoDB client, and here also we have to create the scheduler client and then use create schedule command. So in the handler function of this Lambda, so I am first defining a variable, calculating the time to schedule. So here I will set whatever the date time right now, add 1 more minute. So after 1 minute, we will trigger that Lambda. So these are the parameters. So as for the parameters, I'm giving a name for my schedule. As you can see, this is an random GUID, and then the schedule expression. So this time I'm using one time invocation. So I'm using this at expression at. So it should be something like this, at YYYY and MMDD and the time. So here, once I know the time to send the schedule, I'm going to get that ISO string. And also I'm removing the last millisecond, because in this ISO string, when I convert it to ISO string, we have that last millisecond. So I will remove that and I'll get the rest of it, which is in this format. So that is that schedule expression. And I'm turning off this flexible time window. So I set it mode as off, and this is my target. So what is my target? So it is a notify lambda. So it is that lambda function. So I need to define that ARN. You guys guessed what is this type? So this is that templated type, right? Because I am defining this lambda ARN. So let me show you. So notify lambda ARN, I am taking it from the environment. So when we create this scheduling lambda, I'm also adding some environment variable. So one of the environment variable is notify lambda ARN. You see up here, I created another notify lambda. So this is that notify lambda that is also a lambda function, and that is living in notify folder index.js. So here in the notify folder index.js. So this lambda does nothing but, it will log that event, schedule event received. So whatever the event payload I'm passing on to it, and then I print a log, okay, notification sent. That's all it does. So this is that lambda, and I'm getting its ARN, you see, notify lambda dot function ARM, and passing it as a notify lambda ARN environment variable. So coming back to this, coming back to our target. So that is that ARN. And also I have to use the role that our scheduler should use. So here I'm passing another environment variable called scheduler role ARN. So let me show you that one as well. So this is that role, scheduler role ARN. I have created an IAM role up here. So this is that IAM role, and this IAM role can be assumed by the scheduler. You see the principal, scheduler.amazonaws.com. So what can it do? So I'm providing the permission to invoke this notify lambda. See, notify lambda, I'm granting the invoke permission to this role. So that is the role ARN I'm associating with that. And in addition to that, I'm also adding the DLQ ARN, because I'm also setting up a DLQ. As you can see, dead letter configuration ARN, again from the environment variable. And here, if I show you the stack, I've created a DLQ. DLQ is nothing but a SQS queue here. And then I'm passing its QARN. So to my target, so to my notify lambda target, I'm passing the input as well. So input is whatever the event data that I received in this lambda. So the rule will send all the event input to this scheduling lambda. And when I'm scheduling it, I will pass along that event data as well. So that is what I'm passing here. And here I'm defining my retry policy because I have configured DLQ. And also I have this action after completion. So what do I do once we send the schedule? So here I will set it as delete. So I'm going to delete that event. So those are the configuration, and let's deploy it and see this in action. You can do CDK deploy, and then I will take this API gateway endpoint and then send some payload here. So it will go through multiple services now. So the Lambda will add it into Dynamo. The Dynamo stream will trigger, and EventBridge pipe will get that event and put it in an EventBridge bus. And then what happened, that order create event will trigger the step function. The step function will process the order and then send order complete event again here. And then my scheduling Lambda rule will trigger because we have a order complete trigger here. And the scheduling Lambda is gonna schedule an event in my EventBridge scheduler. And that schedule after 1 minute will invoke our notify Lambda. So let's see if that happens. So this is that API gateway URL. So I have my Postman. So this is that API gateway URL. And this is the payload that I'm passing: passenger ID, passenger name, email, flight details, and the item that he has ordered. And then I will send the event again. Order successfully created. And if I go to the scheduler, I should see that event. Look, so this is that event. And let me open that event. So it should trigger right now, 34, and it's 34 right now. And the target, let me show you the target. So the target is that notify Lambda. So that this is that notify Lambda. And this is the payload. So this is that event payload that I have right now in my scheduler. So it has all the data, right? Notification channel and the passenger details and all that, and also the items that the passenger ordered. And this is that role. So this is the role that it will use to invoke that notify lambda. And the retry policy, if I look here, maximum retention time 1 hour, maximum retry 1 time, and also DLQ. So I have this DLQ configured as well. Okay, let me go back here. Probably my schedule should not show up. Let me refresh it. There you go. The schedule does not show here. That means after the schedule trigger, it will delete that schedule. But let me go to that notify lambda and actually see if there's a lambda invocation. So I'll go to lambda. So right now what I'm checking is if there's an invocation in this lambda. Notify. So this is that lambda. I click on it. Go to the monitor section. View CloudWatch logs. And there we go. I have an invocation of the log stream. So it triggered at 35. If I open it, now I can see the schedule event received, the payload that it received. So it has all the information to send the notification to the passenger, and finally the log message saying notification sent. All right, I hope you guys now understand how to include EventBridge Scheduler in your existing application architecture as well. So with that, I'm going to end this crash course. Thank you very much for listening in, and I'll see you in another video.